so right from the start, I'm going to tell you the hardest part of working out a word problem when it comes to graphing is going to be writing the equation, which you'll get good at because they all start to kind of sound the same, especially when you're looking at linear equations. Um, but really, the hard part for me is not writing the equation, it's figuring out the scale on my coordinate plane if it's not already given to me. So I'm just putting that out there before we get started. So let's go through the process. Trinity is working at Jaymore Farms to earn some extra money over the summer. She started the summer with $52. Most of the time you're going to be given some sort of starting value. That's going to be your constant every single time. So she started the summer with $52 in her account and plans to add, there's add, $20 per week. Okay, in the context of these kind of problems, when you see $20 per week, that's generally going to mean that I am multiplying 20 by the number of weeks. So that's going to serve as my coefficient or my slope, and this is going to serve as my variable or my x value. So the first thing it wants us to do is to write an equation to represent the relationship between time and Trinity's account balance. So we're going to let her balance be y, and we're going to let the number of weeks be x. The reason I'm doing that is because the x value should usually be your independent variable. And what I mean by that is that's the thing that you are plugging in. So if you think about science class, your independent variable is the thing that you get to control. We're controlling how many weeks go by. The balance is going to be what it is based on how many weeks have gone by and how long she's been saving money. So the balance is depending upon the week, which means it's the dependent variable. And your dependent variable is always going to be y. So label your axes. This is going to be weeks. This is going to be your money. Okay? Because x-axis, y-axis. Then it wants us to write an equation to represent. Okay, so y equals, remember I'm always going to try and write it in terms of this y equals mx plus b. So y equals $20 per week, that's $20 times the number, 20, times the number of weeks that goes by, added to that $52 that she started with. So there's my equation, y equals 20x plus 52. Now, here's where we've got to look at the scales of our graph. Weeks, we're going to be counting weeks by ones, right? First week, what's happening? Second week, what's happening? Third, fourth, and fifth, and so on. My y-axis is a bit more difficult because I can't just start with 1 because my y-intercept, that b, is $52. So I'd be way up off my screen, and y'all know my computer would scroll on forever and ever and ever, and this video would be 20 minutes long if I just counted by 1. We don't want to do that. I don't want to necessarily count by anything too big though. If I try to start with 50 and go 50, 100, then that's going to be difficult because I've got 52 as my starting point, which is going to be just a little bit above this first one, and 20 is my slope, so I'm going to have to rise 20, which isn't even going to be a whole 1. It's going to be a nightmare. My vote, I think, is going to be 10 because that starts me out. I could see an argument for 20 maybe, but if I use 10, that means I'm going to be starting right around here at 50. So it's not unreasonable. It's not too high up on the scale. And I'm going up 20. So that's 10, 20, 10, 20. I'm going up 20 at a time. And I feel like that's reasonable. So we're going to fill in just a couple more of those, counting by tens. And then it wants me to graph. Okay, so I'm starting with my y-intercept, which is 52. So that's going to be just a smidge above that 50 line. 10, 20, 30, 40, 50, just making sure I'm right. And then my slope is 20, which remember is a 20 over 1. So that means I'm going to rise 20. There's 10, 20, run 1. So there's my next point. What that means in the context of the problem is that after 1 week, she's up to $72, which makes perfect sense. If she's got 52 and she's adding 20, that's $72. Okay? If I do another point with my slope, I'm rising 10, 20, running 1. Again, in the context of this problem, that means at week 2, I'm up to $92. Well, she added 20 plus another 20, so that's adding $40 to my 52, and now I'm up to 92. You can continue on as long as you want, or you can go ahead and draw your line. Now, I'm going to tell you guys, I'm real bad at drawing these lines by hand. I'm also bad at drawing them with these, but I'm going to try to do it because I feel like it's going to go a little bit better. Unless my computer decides to freeze up. And then, oh, is it going to go? Yay, there's my line. Okay, so then I'm going to draw the little ends of my arrows so that I know that hopefully it's going to continue to increase. She's going to continue to save up money, and it's going to go on forever and ever. So that one, done. Now, in the context of the problem, what does the y-intercept represent? We've kind of already talked about this. The y-intercept was that 52. So in the context of the problem, 52 represents her starting balance, or how much money she had at the beginning of the summer. So starting balance is my y-intercept. The slope was 20. This is not just saying, what's the slope? We know that's 20. You just used it to graph. What this is saying is, in the context of the problem, what does it represent? What it represents is that $20 she saves each week. All right. Hopefully that helps with the word problems. They're really no different from any other word problems. You just get a pretty picture to go along with it. And now my screen's going to scroll forever, so you guys go have fun graphing some lines.